Hey guys, nice job finding this video. So what you guys are going to do this weekend is take some notes on IP17 on the topic of density. You're going to write this at the top of the page, copy down the essential question: how do you describe and measure density? Go ahead and pause this video so that you can set up your notes at this time. One thing I want you to know for these notes is that you do not have to do anything in the question column. You do not have to answer the essential question. We're going to do that together as a class on Monday. All right, before we start, I want to show you this short clip that you guys have already seen, but just as a review.
Density. Density measures how heavy something is for its size. Are its atoms packed close together or far apart? We can calculate density by dividing an object's mass by its volume. Let's see, the mass was 250 grams, and the volume was 1,000 cubic centimeters. 250 over 1,000 is 0.25. So the density of this cube is 0.25 grams per cubic centimeter. Pretty impressive, huh? Okay, now you're just showing off.
So here we go, getting started with our notes. One thing that you need to know about density is that density is a word that describes how tightly packed the matter is inside of an object. This is a picture taken from the video that you just saw. We have two cubes that are exactly the same size, which means that they have the same volume, but the atoms or the tiny particles that make up each object are not the same. This one has particles that are much more tightly packed together than this one, which makes this object way more dense than this object. Density also describes how much stuff is inside an object compared to its size. So how much stuff is inside compared to how big the object is. Obviously, if there's more stuff inside an object, then it's going to be more dense. Therefore, we would say it has more mass, but its volume might stay the same as another object. Let me give you another example. So let's say I had a beach ball and a bowling ball, and I cut both of these objects in half. Well, obviously I would see solid matter in this bowling ball, and I would see like nothing in this beach ball. I mean, if I could cut it in half without deflating it. And so the stuff that's inside of the beach ball is much loosely packed, making it less dense, and everything inside the bowling ball is very tightly packed together, which makes it more dense. Here's the other thing you need to know about these notes. You need to know how to measure density. Density is measured in units of mass per unit of volume. And a lot of people actually define density in that way. That density is a measurement of mass per unit of volume. Meaning, I'm measuring the mass, how much stuff is inside, for how big the object is. Density is measured by mass divided by volume. Here's the mathematical formula you're going to need to calculate density. Now, what's cool about density is that you can use a triangle just like we've used for FMA, just like we used for DST. If you cover up the D, it's mass divided by volume. If you cover up the M, mass equals density times volume. Volume equals mass divided by density. Write this down in your notes also. The unit for mass is grams or kilograms. You guys know this already. The units for volume, you guys know, are milliliters if the object is a liquid, centimeters cubed if it's a solid. Now that means that density units are grams per milliliter if it's a liquid, or grams per centimeters cubed if it's a solid, because it's density equals mass, which is grams, divided by the volume measured in milliliters or in cubic centimeters. On Monday for our warm-up, you guys are going to have to come in knowing how to calculate and describe the density of an object. So finish these notes, go through, highlight whatever you think needs to be highlighted, and then I'll see you on Monday. We'll do the questions together and answer the essential question. Thanks a lot, guys. Have a good weekend.